The first method that we're going to discuss is the method of factorization. So this method will be useful if the given limit is of the form limit x tends to some number f of x by g of x, where f of x and g of x are polynomials. So where fx comma gx are polynomials. So if you have some limit which looks like this, and on direct substitution both f of a and g of a, if they are equal to 0, then we use this method of factorization. So let us take an example. Limit x tends to 2 x square minus 5x plus 6 by x cube plus 2x square minus 16. So whenever you given a limit, so as you can see, this is of the form some polynomial in the numerator by some polynomial in the denominator, right? Some polynomial p of x by q of x. Now what we usually do is first we substitute x is equal to 2. We do the direct substitution first. Okay, so if you do the direct substitution, 2 square is 4 minus 5 into 2 is 10 plus 6 is equal to 0. And if you put x equal to in the denominator, you get 8 plus 2 into 4 is 8 minus 16 is again equal to 0. So on putting x is equal to 2 in the numerator and denominator, you are getting 0 by 0 form. That means that exactly at x is equal to 2 the function is not defined. So it does not mean that the limit does not exist, because when you are dealing with limits, you are finding what is happening as x goes closer and closer to 2 but not equal to 2. So now what I do is limit x tends to 2. We already studied the factorization theorem, which says that in a polynomial, if on substituting some number a, the polynomial becomes 0, then x minus a is a factor of that polynomial. It means if you factorize this, you can get an x minus 2 factor outside, because f of 2 is equal to 0. So x square minus 5x plus 6 can be written as x minus 2 times x minus 3. So you know how to factorize a quadratic. This 5x can be written as minus 2x minus 3x. Next, again here also on substitution of x is equal to 2, this expression is also becoming 0. That means from this also you can take an x minus 2 as common. So if you take an x minus 2 common, what is left out? That can be found by dividing this with x minus 2, right? We just need to find the quotient. So x minus 2, x cube plus 2x square minus 16. So I hope you know how to do the division. So x times x square is x cube minus 2x square minus plus. So 2x square plus 2x square is 4x square minus 16. So x cube plus 2x square minus 16, x cube minus 2x square. So you get 4x square minus 16. So next, minus 4x. So x into minus 4x is, x into 4x is 4x square minus 8x. So minus plus, so these two gets cancelled. You get 8x minus 16. So x into 8 is 8x minus 2 into 8 is minus 16. These two are getting cancelled, you're getting 0. So dividend is equal to divisor into quotient. X square plus 4x plus 8. Now let us use our logic. As x tends to 2, that means x is closer and closer to 2, but x is not equal to 2. Hence x minus 2 is not equal to 0. Hence I can cancel out x minus 2 in the numerator and denominator. So once I cancel this out, this is equal to the limit x tends to 2, x minus 3 by x square plus 4x plus 8. Now again, this is of the form polynomial by polynomial. Now you do the direct substitution again. So is the indeterminacy cancelled? Yes. 2 minus 3 is minus 1 divided by 4 plus 4 plus 8. That is 8 plus 8 is 16. So this time you are not getting an indeterminate form. Hence you can do the direct substitution. Hence the value of this limit is equal to minus 1 by 16. So I hope you understand the basic process. So let us do another example to reinforce this idea. So next, let us try to find this limit. Limit x tends to root 2 x power 4 minus 4 by x square plus 3 root 2x minus 8. So again, this is of the form limit x tends to some number f of x by g of x. The numerator is a polynomial of degree 4. The denominator is a polynomial of degree 2. So in that case, let us use direct substitution. So if you put x is equal to root 2, so you get x power 4, root 2 power 4 is 2 square. So 4 minus 4 is 0 by, if you put x equal to root 2 in the denominator, x square root 2 whole square is 2, 3 root 2 into 2, 6, 2 plus 6 minus 8 is again equal to 0. So you are getting a 0 by 0 form. Now, whenever you get 0 by 0 form, we use the process of factorization. So how do we do this? So on substitution of x is equal to root 2, this has become equal to 0. Hence x minus root 2 is a factor. So if you can directly separate it, that will be very good. So we know that x square minus 4 is x square plus 2 into x square minus 2, and x square minus 2 is x plus root 2 times x minus root 2. So this is a very straightforward factorization. So x plus root 2 into x minus root 2 is x square minus 2, x square minus 2 into x square plus 2 is x square minus 4, divided by x square plus 3 root 2x minus 8 is x minus root 2 times, so we know that x minus root 2 is a factor. So without direct division, if you want to directly write the other factor, so you can compare this and write the actual factor. As you can see, you have x square here, you have x here. So you need to have an x here such that you get x square. So x square is adjusted. So minus root 2x is already there, but I want plus 3 root 2x. So minus root 2x, I want plus 3 root 2x. So I need to add a 4 root 2x, right? So plus 4 root 2. So minus root 2x plus 4 root 2x gives you 3 root 2x. Minus root 2 into 4 root 2 is minus 8. So once you do this factorization, as x tends to root 2, x minus root 2 is not equal to 0, and I can cancel out these two. Now as you can see, that indeterminacy has been cancelled. So once indeterminacy is cancelled, I can do the direct substitution. So x square plus 2, 2 plus 2 is 4 into root 2 plus root 2 is 2 root 2 divided by root 2 plus 4 root 2 is 5 root 2. Root 2 and root 2 gets cancelled. You get 8 by 5 as the answer. Thank you.